Hello, everyone, and welcome to today's episode. We're going to explore a fascinating intersection of artificial intelligence and practical application. Specifically, we're discussing a recent research paper that addresses a common issue in large language models, or LLMs, the problem of hallucination when generating structured outputs like JSON workflows. Now, if you've been following the developments in AI language models, you might be familiar with the term hallucination. In this context, hallucination refers to the tendency of language models to produce outputs that are nonsensical or include elements that don't actually exist. Imagine asking an AI to generate a workflow for a database operation, and it invents steps or references tables that aren't part of your database. This is not just a minor glitch. Such hallucinations can lead to significant errors in real-world applications where accuracy is paramount. Palatia, intro, session, sexuality. To tackle this challenge, the authors of the paper have employed a technique known as retrieval augmented generation, or RAG. This approach combines the strengths of a retriever model and a language model to produce more accurate and reliable outputs. The retriever model is trained to align natural language inputs with relevant JSON objects. Essentially, it acts as a bridge, mapping user requirements to plausible workflow steps and database table names. Here's how it works. When a user provides a query or a set of requirements, the retriever searches through a repository of known JSON components to find those that are most relevant. These retrieved elements are then included in the prompt provided to the language model. By grounding the language model's generation process in actual data, the likelihood of hallucinations is significantly reduced. The training process for both the retriever and the language model is quite sophisticated. The retriever is trained using a method called contrastive loss on pairs of natural language queries and their corresponding JSON components. Negative sampling strategies are employed to improve accuracy. This means that the model learns not just from correct pairings, but also from deliberately incorrect ones, enhancing its ability to distinguish between relevant and irrelevant components. On the other side, the language model is fine-tuned using a supervised approach. Training examples are augmented with the retriever's output, providing the model with contextually accurate information to base its generation on. This integrated approach ensures that the language model doesn't stray off topic or invent non-existent elements. The results showcased in the paper are impressive. Compared to methods that rely solely on fine-tuning the language model without the retriever, their approach significantly reduces hallucination. One of the standout features of this method is its ability to generalize to out-of-domain settings. In other words, the model can handle queries that are outside the scope of its original training data without sacrificing accuracy. Moreover, by incorporating the retriever, the authors found that they could utilize smaller language models without performance degradation. This is a substantial benefit because it reduces computational overhead, making the system more efficient and accessible for practical use. They evaluated their system using custom datasets derived from real-world workflows, which adds weight to their findings. The datasets were tailored to reflect genuine use cases, ensuring that the model's performance was tested in realistic scenarios. Additionally, they introduced specific metrics to measure hallucination, focusing on the presence of non-existent steps or tables in the generated outputs. An interesting aspect of their evaluation is the error analysis. It revealed limitations in both the retriever's recall and the language model's comprehension of complex logical structures. For instance, the retriever might miss relevant components, or the language model might misinterpret intricate relationships within the data. Recognizing these limitations is crucial because it highlights areas for future improvement. One of the key advantages of separating the retriever and the language model is the ability to optimize them independently. This modularity not only allows for targeted enhancements to each component, but also opens the door for reusing the retriever in other applications. For example, the retriever could potentially be applied in different domains where aligning natural language with structured data is beneficial. The authors also propose intriguing avenues for future work. They suggest improving the synergy between the retriever and the language model. The enhancing this interaction could lead to even greater reductions in hallucination and better overall performance. Optimizing response time is another area of focus. Techniques like speculative decoding and streaming outputs could make the system faster and more responsive, which is essential for real-time applications. Exploring different output formats, such as YAML, is another interesting direction. By supporting various structured data formats, the system could become more versatile and cater to a wider range of use cases. To put this into a broader context, the issue of hallucination in AI models is not just a technical problem. It speaks to the trustworthiness and reliability of AI systems. As these models become increasingly integrated into critical applications, from healthcare to finance, ensuring their outputs are accurate is of paramount importance. This research contributes to a growing body of work aimed at making AI systems more grounded and reliable. It's reminiscent of a quote by the famous statistician George Box: "All models are wrong, but some are useful." The goal here is to make models not just useful, but also trustworthy by minimizing the ways in which they can go wrong. The use of retrieval augmented generation is a testament to the innovative approaches researchers are taking to address AI's limitations. By combining different techniques and models, we can overcome challenges that seem insurmountable when using a single method alone. In the realm of natural language processing, balancing creativity and accuracy is a persistent challenge. Language models are designed to generate human-like text, which inherently requires a level of creativity. However, when specificity and correctness are required, especially in structured outputs, that creativity can lead to problems like hallucination. The approach discussed in this paper strikes a balance by providing the language model with concrete, relevant information to base its generation on. This research also highlights the importance of interdisciplinary work in AI. It brings together concepts from machine learning, natural language processing, information retrieval, and software engineering. Such a multidisciplinary approach is often where the most impactful innovations occur. For those interested in implementing similar systems, it's worth noting that the retriever and the language model's separation offers practical benefits. Since the retriever is trained to align natural language with JSON components, it could be adapted to other structured data formats or different domains entirely. This flexibility makes the approach scalable and adaptable to various industries. Huh. Uh, it's in terms of real world applications, think about how this system could improve the generation of code snippets, database queries, or even automated workflow configurations. Businesses could leverage this technology to automate complex tasks while maintaining a high level of accuracy. It's also fascinating to consider how this approach could benefit smaller organizations or developers who don't have access to large computational resources. By enabling the use of smaller language models without sacrificing performance, the barrier to entry is lowered, democratizing access to advanced AI capabilities. As we look ahead, the continuous refinement of these models will be crucial. Techniques like fine-tuning, negative sampling, and contrastive loss are powerful tools in the machine learning toolkit. Yeah, I think, however, the human element, careful curation of training data, thoughtful consideration of model architecture, and rigorous evaluation remains indispensable. In closing, this research represents a significant step forward in addressing one of the key challenges in the deployment of AI language models in practical settings. By reducing hallucination through retrieval augmented generation, the authors have contributed valuable insights and tools that can enhance the reliability of AI systems. Thank you for joining me on this exploration of cutting edge AI research. It's an exciting time in the field, and advancements like these show great promise for the future. Stay tuned for more discussions on how technology continues to shape and improve our world.